This conference will now be recorded.
Good morning, friends. Welcome to GoOnlineTrainings.com. So far, we're able to understand how to store the data and how to retrieve the data from the SQL server. Okay, we write normally stored procedures, or you write the functions, or you may write the queries. So whatever you write, you have to hit the table and do some kind of an aggregations and get the data and deliver the data to the client applications or display the data onto the screen. So this is what the SQL Server is going to be doing. When you have a small amount of data, then you don't have any kind of a performance issue. Okay. So when you have 1,000 rows, 2,000 rows, 10,000 rows, 50,000 rows like that, when you do any kind of a calculation, simple calculation I'm talking about, get me the total sum of the balance value. So you can say select sum of balance from the table and it can give you when you have less amount of data. The user is very, very happy because the data will get displayed in fraction of seconds. But when you have large amount of data in the table, when you hit the same query, select sum of C balance from the account master table, or you may write where the branch ID equals to BR1. So when you write the query like this, what's going to be happening when you have large amount of data, it may take a lot of time. When the retrieving portion is taking a lot of time, then definitely end user will not be patient and he'll be complaining about the application. So he'll see that the application is not so good, the application is very, very slow. I'm not able to get the data, whatever I needed. For example, simple balance, I would like to get it. So what is the query normally? Select the balance from the account master table where account ID equals to your number 1234. So when you hit this query, if it is taking a lot of time, then definitely the people will complain saying that you know the SQL server is not doing well, the application is very, very bad. Okay, so when you have a limited data in the table, you don't have to worry, and always the SQL Server or Oracle is very, very faster. So in the real time, you cannot see 67 rows. You will see thousands of rows there or millions of rows there. But since it is a training machine, I don't have the unlimited data, or I don't have, a millions of rows here. But when I say I would like to retrieve only my balance, normally what you do, you say my balance. There is a column called C balance column, right? So on the C balance column, we would like to display account number, whatever be the account number you will insert into the database or into the ATM machine. So it is able to give you very, very quickly because I have a limited data. You think about if you have 10 million data, 20 million data, and if you issue the same query, will it work in the same manner how it is working? The answer may not be yes. Okay, because whenever you hit something, so it has to go to the table and fetch the data exactly wherever the 101 is stored in the table. We don't know. We have millions of data. Where this exactly stored, you and me do not know. It has to go to the particular, extend particular page and get the data. Okay. So why we have to create an index? The first question people would ask you that why indexes are important. Okay. The indexes are important if you wanted to retrieve the data very, very quickly or a very, very faster manner. Okay. So if you don't have any index, what is going to be happening? It is going to be performing what is called a table scanning, or what is called simple scanning. It's going to be taking. So what do you mean by scanning? For example, I would like to get the data, C balance from account master table where account ID equals to 101. If you're in the first, place, then you will be retrieved very, very quicker. If you're in the last page, and it will take a lot of time. Let me give you a simple example so that you would can understand very, very easily. Okay. Normally, in the real time, what happens is that whenever you go in for an indexes, let me create a table first. Okay, I'm creating a table in the SQL Server. Now, this is my table. Okay. The table name is called account ID, and the name of the customer, the city in which the account has been opened, then he has got lot of other information. So this is some an employee table. Okay, let me say simply employee ID, employee name, employee city, and I would like to show you some information here. Right? Okay. Now let us talk about some data. So employee one. Let us say John is currently working for some city called Chennai. Okay. And let us say Mary is working from some city called Chennai. And see, I have Mahi is working for a city called some Hyderabad. Okay, let me have some cities. And we have Vineet is working for city called Bangalore in India. So like that, you have millions of data. Have it. Okay, I have, let us say, Hari is working for a Hyderabad city. Now the question is that I would like to have the numbers could be any number. I don't know. Some numbers are available. Okay. And randomly I have inserted the data. So this is the data I have in my table. Clear? Now I would like to write a query, a simple query I'm writing. Select star from employee table where I would like to get where city equals to, let us say, Bangalore. Okay, so this is the query. I wanted to retrieve the data from this. Now, what I'm going to be doing, I will be able to write the data like this, the query like this, and hit. So when you hit, the SQL server does not know. I don't have any indexes on this. Try to understand. I don't have any indexes on the table. It is a simply table with employee ID, name, city, nothing else. No primary key, no unique key, nothing is there. Okay, simply I have created a table and there is no index, there is no primary key, there is no nothing is there. So when you don't have any indexes, people will say the table is in the heap structure. So that is what the people are going to be telling. Okay, so if you don't have any indexes, if you don't have a primary key, foreign key, people will say that the complete table is available in the heap manner, heap structure. Okay, when you learn C language data structures, we have a heap, we have stack, lot of the we have a queue, lot of things are available there. So what do you mean by heap? Let us understand. Heap means there is no sequencing order. For example, I have a room. Inside the room, I kept my laptop. Next to that, there are shoes. Next to that, there are some lot of books are available. Next to that, there laptop. And after that, I have a close. So the room is not organized properly. Heap means unorganized, not organized. So that is the meaning of a heap. For example, however you're going to store the data, the same way in which the data is got organized internally inside the database, there is no proper data organization. For example, if you don't organize the data properly, what's going to be happening? For example, if I have a small room, I'm keeping laptop, pen, pencil, shoes, lot of books, and everything is there. Okay, I wanted to get a book from there. So what I do, I don't know where the book is available. I should go to my room and search. Is it the book? Is it the book? I have to search everywhere. Finally, I will be able to get the book. Since it is a small room, I can easily search, even though I don't organize the things. I don't organize these things, but I can search for 2 minutes, 3 minutes. I should be able to get the data. Okay. The important thing is that data storing is important. At the same time, data organizing is very, very important. Okay. For example, I have a big home. I'm getting a lot of items, but I'm not organizing it. So if you organize, for example, I have a kitchen items. I'll be placing in the kitchen. I have a toiletry items. I'll be placing in the toilet. I have a lot of room items. I'll be placing in the living room or dining room, something like that. I am getting the items from outside. I am organizing the data inside my home, or I am organizing the data in my table. So a lot of people think that if I insert the data, it doesn't mean that you're organizing the data. You're placing the data properly. Clear? So when you create an index, what happens is that internally the data storing plus the data organization is going to be happening there. Let me give you a simple example. I have big campus or I have a lot of big godowns over there. So where the food is going to be supplied in India, we have a Food Corporation of India where you will have a lot of items over there. You will have rice, you will have wheat, you will have flour, you will have coconut, you have vegetables, you have stationery. Lot of items you're planning to dump into one big area called. Let us talk about. So 100 acres of land you have where you're planning to store a lot of things over there. So you're dumping rice bags, you're dumping wheat bags, you're dumping a lot of pizza items, raw material, soups, or stationery, then computer laptops. You're dumping a lot of items in the 100 acres of land, and after that you're not organizing it. Somebody comes and asks me, give me one packet of pizza items, or give me one packet of rice bags. If I ask you, in this 1,000 or 100 acres of land, where will you go and how do you get the data? So it is very, very important. If somebody asks you tomorrow, I need 1 kg of rice or I need 1 kg of sugar, you're getting complete items and dumping, getting a lorry by lorry, getting lot of items and dumping into the big godowns, and you are not organizing the items properly into the godowns. If somebody comes and asks me, give me 1 kg of sugar or give me 1 kg of rice or one bag of rice, you don't know where the rice bags are available in this 100 acres of land. So that is means it is not the storing data is important. It is always storing the data plus organizing the data internally inside the database is very, very important. Clear? If you don't organize the data, the structure is called as a heap structure. So inside 100 you know acres of go down, you are not organized, simply getting the items by lorry and dumping, and lorry is going, and one more lorry comes and it dumps the stationery and it goes, and you will get one more lorry, it dumps oil packets and goes, get one more lorry and dumps lot of laptop items and goes. So we are not organizing nothing, only we are inserting the data, and we think that insertion is okay, once it is completed, you think that it is sufficient to retrieve the data. It is not sufficient. So when you have the data, for example, I would like to know the query now. So what is the query? The query is very, very simple query where city ID equals to Bangalore. I don't know where the city ID is Bangalore. So what the SQL server is going to be doing, it is going to be going to the first row. It is going to be verifying that is it, Bangalore. So that's what it is not. So it is going to be going to the next row. Is it Bangalore? No. Is it Bangalore? No. Is it Bangalore? Yes. Is it Bangalore? No. Is it Bangalore? No. So it is going to be verifying a row by row, row by row, row by row. You're lucky when you have a 5 rows, you can get it quickly. Okay. But if you have millions of data, it has to row by row, row by row, row by row. So that is what is called table scanning. Okay. So SQL Server is going to be performing, or Oracle is going to be performing a, a quick operation called table scanning. Table scanning means searching row by row. Okay, when you're searching row by row, the table scanning is very, very slow operation. Okay, because I told you I don't know where the rice bags are available in my 100 acres of godown. So how do I do this? I have to go to somewhere and start from there continuously. Is it right bag, rice bag? No. Is it rice bag? No. Is it a rice bag? No. If you have thousands of acres of land, you have to go row by row, row by row, row by row. Then you will be, losing a lot of time, because table scanning means starting from first row to last row. Read the data row by row. Okay, read the data row by row from first row to last row. Okay, so this is what will happen if you don't have any data organization in your database or in your table, because the table doesn't have any kind of an indexing mechanism. The table doesn't have anything. The table is simply storing the data and the table data is available in the heap manner. Heap manner is the data is not organized. Clear? Okay, whenever the insert is happening, you simply keeping the data. For example, tomorrow I'll get one more row here. You will be keeping the row as it is. So there is no data placement or data organization here. So something like this, you will be having the data. Clear? Okay. Let me go to the go down example once again. So whenever the people are trying to get the data from the big go down, you don't know where the exact data. So you will be doing a operation called table scanning. Clear? So you will hit, you will go to the first place and check, is it rice? No. Is it rice? So you will be roaming and roaming and roaming and roaming. And after 1 hour or 2 hours, you will give me a rice bag. That definitely the people will be not happy about your operation, whatever you're doing. So you will get an idea. Okay, this is not the way I should organize my things, because you have thousands of acres of land where you're dumping a lot of items over there. It is a big go downs. So what I have to do, you will say that let me construct or let me organize the items properly in this go down. So what you do in this go down, I'm talking about, you have not, the data is not stored in the heap manner. It is now the data organization is going to be taken place. You think about, this is your 100 acres of land. Okay. I'm talking about 100 acre. Okay. So this is the land, open land available. So here what you do, you construct a lot of, rooms. Okay, lot of rooms are available now, or lot of sheds are available. So like that, what you do, you're going to be organizing the data. For example, you give, this is a room number 1, this is room number 2, okay, this is room number 3. Like that, you are, creating a lot of things. Then later what you do, you have lot of rooms are available in this. So whenever you get some kind of items, you will be dumping into room number 1. For example, in the room number 1, you kept the rice bags, and the room number 2 also, you kept the rice bags. Okay, in room number 3, you have a lot of stationery items. Okay, lot of stationery, pens and books, lot of things are available. Okay, that, so the books are available here. You're, storing a lot of fruit items. So like that, you have divided the data completely and organized them in simple rooms. After that, what you do, you come to wherever you sit. Okay, you will be having a cabin at the gate, right? So you have to come to your room, and you create what is called an index page like this. Okay, so this is you, that you will be sitting at the entrance of the gate. Okay, so whoever comes using the gate, they have to come and ask you, okay, I need something, I need something. So this is you, you will be sitting in front of the go down, and you create an index page. Now how do you create? You will create like this. For example, somebody needs rice bags. Okay, you say that rice bags are available in room number 1 and room number 2. This is what is called index page. And if somebody needs the stationery, pens and everything, the stationery is available in room number 3. Okay, then you write an index saying that if somebody asks a fruits, the fruits are available in the room number 4. So this is the index page that you are going to be creating with you, and you will be, always, keeping with. If somebody comes tomorrow and asks you, hey guys, I would like to get the fruits. Now what you do, what kind of a fruit you need? So first you need to, when you hit the query, when somebody comes from the external part and they're trying to ask you something, I need this, I need that. So these are the data pages, how the data is organized. Clear? So these are the data pages. Internally data is organized in the form of, pages and extents, and every page will have a numbers and everything. Clear? So however, we have a room number 1, room number 2, room number 3, room number 4, you have organized the data like this. Now you have organized everything, and after that you're creating an index page. The index page where the SQL server, this guy is called SQL server. So whenever you hit something, for example, I would like to write a query here. Select star from this room where, the item equals to fruit. Okay, very simple query I'm writing. Okay, the item equals to stationery, item equal to fruit, whatever you would like to have that thing. that you need to mention. When you write the query and submits to the SQL server, what SQL server is going to be doing? SQL server, this is a SQL server. SQL server is going to visit the index page first, and whatever is available in the where class, okay, it is going to be verifying, okay, fruits are available in the the page number 4, or the room number 4. The SQL server is going to go to from here. First it will hit the index page, and after that it will take the address which is available in the room number 4, and it exactly goes to that, and SQL server is going to be getting the data, giving the data to the external world. That's it. Indexing concept is very, very simple. Okay. So when you have a big SQL server, you think that this is your SQL server, and all the data is not organized. Okay. So not organized means the data is like this. It is not organized at all. So when you create a, or when you create a index, what is going to be happening? First, you need to organize the data. If you wanted to create an index page, you should be able to organize the data. If you don't organize the data, then you cannot create an index page. For example, you're dumping everything into one room and you would like to create an index. What will you create? You will not be able to create. What you do? First, you need to organize the things. Keep all the stationery into one cupboard. Keep all the trousers and pants into one more cupboard. So keep all the items into one more cupboard, so that you need to organize the data first. Step number one. After the organizing the items like this, then after that you can create an index. Okay, if the data is in heap structure, if the data is like this, if there is no organization of the data, you cannot create a index page. Okay, try to understand that point first. Okay, to create an index, first you have to organize all items in a single manner. The organization based on the city, or based on the name, or based on the employer, it is something you need to use and organize the data properly. Clear? So here I'm going to be organizing based on the item type. All the rice items, I'm keeping it together. All the stationery, I'm keeping it together. All vegetables and fruits, I'm keeping it together. If you wanted to create an index, the step number one is that you have to organize the data. You need to sort the data. You need to organize the data. This is very, very important. If you don't organize it, you cannot create a index page like this. You cannot refer this. Okay. You need to organize the data first, then later you create a index page. Okay. So that is normally we do. So what we have done, we're getting lot of items to the go down, but later after the lorry is dumping items in this room, I am, calling my labor, and they're organizing the items inside the room. For example, I have a lot of coconuts, lot of items I'll be dumping here. But if I have a lot of, stationery, I'll be putting here in this room. If I have a lot of things here, I'll be, putting this. So what is going to be happening? It is organizing the items, depends upon however you would like to have it. Okay. So you can say grouping, or you can say sorting. So whatever you would like to say, you can say. So that is what is called organization. Clear? So then what is going to be happening? Index page is also created. So let me give you one simple example. Whenever you buy a book, so table of content is available, right? So table of content is nothing but an index page only. Why the table of content is important? Because I would like to read a chapter on stored procedures. Now what you do? You have to go to the table of content, that is what is called index page. It says that stored procedures are available in page number 198 in this book. Now you hit the index page, you try to search where is the stored procedure, and you're going to be going to the page number, and you go to the page number and you hit the page number of 198, and you will be reading it, right? So however, you're hitting the index page first, and later you will be hitting the data pages. Now try to understand, I am talking about two types of pages. One is called a data page, then one is called index page. So the day one, we were discussing about MDF file. Do you remember? So MDF file, I was talking about where you have a lot of data. So lot of data file, lot of data will be there. But what the data? So index, sorry, the MDF file is going to be organized. Okay, so this is my MDF file. So I told you the day one itself, this is organized by page numbers, page one, page two, page three. Do you remember this? So page four, like that, it is going to be organizing, and each and every page will be having a page number. Okay, page number one, page number two. However, I had kept the room numbers here, right? So this is a go down. We have a room. So this is a page here. There is a page numbers are available in this three, and you have a four, lot of things like this. Okay, so I told you 8 pages are called, an extent. Now what is going to be happening, whatever be the table you have created, you may create employee table, you may create any account master table, whatever be the table you create, all this data will go and store in the page number one, page number two, page number three, page number four. All the data is going to be organized in the pages. Okay, now however you're storing the data, the same way the data goes in and sits. For example, tomorrow I would like to get where a simple thing where employee ID equals to 123. Okay, 133. I would like to search. Now, if I don't have any organization, is it 133? No. 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 I don't have a clue whether this exists or not. To tell that also, the SQL server will take a lot of time because the data is not organized properly and the data is in the heap structure. Clear? Now, what I'm planning to do, I would like to create an index. Okay. If I wanted to create an index first, because I know that I am doing a table scanning. SQL Server is doing table scanning. So I would like to search. I'm not getting anything, even though I give a employee ID equals to 12. Okay, so it is taking a lot of time because I have millions of rows in the table. Okay, and it is doing a table scanning. Clear? So that is what is very, very important. Now you're going to be organizing the data not in the heap manner. I would like to have the data into the a structured manner. So you create an index on it. Okay, when you create an index, what is going to be happening internally? Let me take this data and let me show you. So I would like to create index in this table. Okay, now when I'm creating index on this table, because indexes can be created not on the tables, on the columns. Okay, normally we create index on this column because I would like to know the organization based on this. So when I create an index, especially for the clustered index, the step number one is that the data is organized. Okay, when we create an index, okay, the step number one, what the things would happen, first the data is organized on that column. Okay, whatever be the column you have used, on that column the data is going to be organized. So clustered index, what it is going to be doing, it is going to be sorting the data by default in ascending order on that column. Okay, now I'm using employee ID. On that column I am creating a one index. Okay, forget about what type of index I'm creating, but I'm creating an index. Okay, let us understand now. I am creating an index called, there are two types of indexes in SQL Server. I'm going to be creating a indexing called clustered index. Okay, so what are the indexes you need to go apart from the heap? Okay, so the types of indexes in SQL Server, we have only two as of now. So one is called clustered index. Okay, clustered index you can create. The second index you can go in for non-clustered index. Okay, there are two indexes which are available inside the SQL Server. Types of indexes in SQL Server. So that is called clustered index and the non-clustered index. But if you don't need any indexing, nothing. I told you that that table is in the heap structure. Okay, I don't want to maintain the data in unorganized manner. I would like to create some kind of an index. So because I would like to retrieve the data very, very quickly. So if I wanted to create an index, this is my index I am created. But if I wanted to create the index, we should know that first we need to organize the data properly. So however you have stored the data, in the heap manner. There is no index on this table. The data unorganized, not organized properly in this data pages. Clear? But now I am creating an index. Now what is going to be happening? The data on this will get sorted. That is the organization of the data. The step number one it is going to be doing. When we create an index, and now let us talk about clustered index. When I create a clustered index on a column called employee ID, now the data is organized. So it is going to be sorting the data based on ascending order. So you can also give a chance that you can also create the sorting in this index. So by default, SQL Server organizes all the data into the ascending order of that column. Okay, now what is happening here? So the data will not be like this. So the data will get sorted like this. Let me go and sort the smallest to largest. Okay, so the data is now organized. So the first number, the first employee is Mahi, will be the top, and the second employee is 8, that is Vinit. Then we have Hari. Now we have 55 Mary. Then we have a John, and you have a Bhaskar. So this data is in the heap structure. You don't have any organization. There is no proper organization. But when you create a clustered index on this column, so what happens is that this is having an index. Okay, so this is having an index. If you need what index it is a clustered index. Okay, when I create a clustered index on any column, so I can create on this column or on this column or on this column, whatever you wanted to search. I would like to search based on the employee ID. So I've created a clustered index on this. When you create a clustered index, step number one, the data is organized properly. Step number two, it is creating an index page. Okay, it is going to be creating what is called an index page. That is what you need to understand. Two things would happen internally. So create index page. Okay. So however, you have a table of content that is an index page, but after that you have a lot of data pages where you can read about the stored procedures, right? Introduction to SQL Server, introduction to stored procedures like that. Those are called data pages. Now, when you go to R diagram, what is going to be happening inside MDF? You will have a lot of pages, but in the initial pages, so the page number one, page number two, these pages are called index pages. Okay, it will create an index, and the page number three, page number four, these pages are called as data pages. Clear? So however you buy a book, the first couple of pages, some 10, 20 pages are completely index pages. Later you will have introduction chapters and everything will start. Okay, those are called data pages. Now MDF is going to be having two kinds of pages. One is called a data page. Now the other one is called index page. But all these are physical pages that you need to understand. Many people think that index is not a physical, it is a logical. No, logical means it will not be there permanently. Just like a RAM. Whenever you keep something in the RAM, when you come out, it'll go away. So it is not something physical which exists daily. Okay. So index pages are permanent pages which are not logical pages, or which is you never think that it is not going to be there tomorrow. No, it's not like that. It is going to be occupying space. So when you buy a book, you will have a 20 index pages, table of content. Is it a physical page or logical page? It is there till the book is there. Clear? So it is not a small page. You need to understand a index also will take a lot of space from the hard disk. And when you have a large amount of data in the tables, the index pages itself will be 100,000, 2,000 pages. It has to scan. Okay. Then after that, you will have a lot of data pages. Clear? So what kind of the pages the SQL Server is going to be maintaining? You have index pages, and you have also data pages. And whenever you create a index on that column, what happens is the step number one, the data is going to be sorting on that column. Now think about, you have already 10 millions of data. Now here I have only 6 rows. I'm able to do the sorting very, very easily, right? You think you're having already 10 millions of data. Now freshly you're creating a clustered index on it. So the first time it has to take all the data from wherever it is stored, and it is sorting. Okay, it is sorting all the data, then later it is going to be organizing them. Later it is going to be organizing. Clear? So the data will get organized like this only. So if you don't have any indexing, it is a heap. So it is, the numbers are not sorted, no organization takes place here. So let us understand what are the pluses and what are the minuses in this. So I have data in a heap. Okay, I have data in heap, or I may have data in indexes. Okay, so let me talk about these two things. When I am writing data, when I'm writing data means, so you have a select, let me say insert, let me, these are the operations normally we do: select, insert, update and delete. So these three operations are called writing, and this operations called reading. So normally we have heap and index. When you have a heap and index, let us understand what is going to be happening. Okay, so if you wanted to read the data randomly, for example, I would like to know employee ID, where employee ID equals to slow. So I'll be doing a table scanning row by row, row by row. I'm doing because the data is not organized properly. So the selecting reading will be very, very slow. So that is what is the disadvantage of the heap structure. Okay. So when you reading the data or selecting the data from the table, it will be very, very slow. Okay, reading is select. Writing is insert, update, delete. So reading and writing operations we're talking about when you don't have any kind of a index pages in your table. So this is very, very fast. For example, I would like to read something. It will take a lot of time because you're performing row by row. The next one is that I would like to insert the data now. So a lorry comes and dumps all items and it goes away. So insert is also, for example, I would like to insert a row here. So there is no problem. You should be able to insert a row called, let us say 24. 24. We have Shiva from Bangalore got inserted. There is no issue. The insertion is very, very faster. There is no issue here. Okay, then I would like to update. For example, tomorrow his number is not 123. I would like to update the number to something else. I can go, and again updation here you need to search where is the number, and you need to do is, but still you can say medium faster. You need to do, you need to find where is that guy and you need to update. Then I would like to delete a row. I would like to go simply delete a row. So when you're doing this kind of a things, and writing is a bit faster here, but in the heap manner, what is slow, the reading is very, very slow. Okay, for example, whenever you plan for OLTP applications, whenever you plan for OLTP applications, we already know that OLTP is good in the writing capability. Writing capability means insert and updates and deletes should be faster. And even though the reading is a little slow, that doesn't matter, but not very, very slow. Okay, so when you don't have any kind of a this one, then we're talking about, so the writing is a bit faster. But now when you create an index and organize the data like this, tomorrow I would like to insert the data. For example, I'm inserting a same row 24 Shiva BLR. So let me insert here. When I insert, so the row should not sit because the data has to be physically sorted, right? So when you store the data in 24 Shiva Bangalore, SQL Server has to get some space because there is no space after 12, because I have to appropriately insert the space here. What SQL Server has to do, SQL Server has to go here and insert a space first. However, I'm doing it. Create a space. Now take this row and place the row, and after that the data will be in the sorting manner. See, when you insert the data here, you're able to insert at the last. There is no issue because data is not organized or not sorted in any manner. But when I'm inserting some data here, so that row you cannot insert, the row you cannot insert here, the row has to be inserted properly here. Okay, so that means first SQL Server has to verify whether I have sufficient data, sufficient space in the table or not. If there is no space is available, I have to create a space first, and later I'll take the data and I'll be inserting the row here. Because of this sorting, because of this indexing mechanism, what is going to be happening when you have an index, this operation will become very, very slow. Clear? But when you need the data, for example, I would like to read where employee id equals is 12 or where employee id equals to 13. If I wanted to read, I create a index, on a page saying that this is available in so and so page, these numbers are available in so and so number. For example, I'll say in a simple, so employee ids, I'll write like this: employee id 1 to 10 are available in page number 1. I'll say employee id 11 to 20 are available in page number 2. So that is how I'm going to be organizing the data. So I'll say 11 to 20 are available in page number 2. I'll be writing like this. If somebody says that I would like to get where employee id equals to 1, I simply go to employee id 1 means I have to go a page number of this, okay, where I kept 10 rows into this page, next 10 rows into this page. I'll be creating an index page like this. Clear? So if somebody asks me where employee id equals to 13 or 15, I know that that is available in between this. I have to go to page number 2 physically and get the data from there. Okay, because the data is organized. Then later the index page is also created like this. Row numbers are the this one. So at the end, you will be organizing all this data into pages. Now in the page, it will be 8 kilobytes. Let us understand that you will have 10 rows or 20 rows for each page. Okay, the data is filled in now. The data is filled in 10 rows, 10 rows, 10 rows. You have got it, but suddenly you're inserting a row here. When you're inserting the data end of the day should go to this page. For example, it has to go to the fourth page. Now when the fourth page already you have 10 rows and there is no space there, so how do you organize the data? You need to shift at least some of the rows to the next page, and this data to the next page, this data to the next page. It will take a lot of time, right? It has to splitting the data from one, or this one to another. So this is where the SQL server has to worry, because when you're inserting the data has to go to the appropriate data pages. Clear? I cannot keep all the data in this last page where I have a space. But if it is in a heap structure, whenever you insert the data can come to the last page. Okay, but when you have index pages, the data need to be organized like that. So SQL Server will go here. So for example, the data supposed to come to the third page or the fourth page. First is just to verify whether I have the space or not here. If there is no space, it has to accommodate the space in the third data page, and it has to pull the data and come here, and you need to adjust the indexing also. For example, you're creating something new tomorrow. For example, getting a new item. So say I am also putting a stationery and computer bags here, computer stationery, computer laptops also here. Okay, when you're organizing something, you need to mention here also, right? In the room number 3, not only stationery, I'm also putting computers. So when you put the data somewhere in the page, and the same information has to be reflected onto the index also. Clear? So it is not only the data pages you're inserting into. At the same time, you need to say the index page. So here you need to mention the stationery and the computers also I'm keeping into this room. So lot of index also you have to update. So this is the two time. One is that you need to update the data here, and the second time you should also create, if there is no index, you need to create appropriate indexes for that. Otherwise nothing will happen. So whenever you insert the data, it is slow here. So whenever you update the data, for example, tomorrow you came, you have updated Hari number to, let us say, 321. The employee ID itself you have updated. Now, when you update, can you keep the data as it is here? No. According to us, the data has to be in the sorting manner. So you have to take the row from here, which was sitting in the page number 1 or 2. That row has to come out of this, and it has to be going here. Okay, so what is going to be happening when you update here? For example, I go to Hari, I'll simply update. There is nothing will happen, it will be there, that's it. But if I update, so the deletion, the data would happen from here. and the data has to properly again reorganized and kept it. Clear? So all these things internally SQL Server is doing that we are not aware of that. Because of this, changing the number, taking the data from this and reorganizing the data. Now you need to again update, these pages also, because you may not be having the 321 page now got extra. So this one also you need to update. For example, 320 to 3, something like this. If you have more and more data, 330 data is available in say page number n, we don't know some n, or page number, let us say 677, which is available. So this is also it has to update it. Okay, so updating is slow, and deleting also. For example, when you delete the row, and that is also it's going to be taking a bit of time, and it has to reorganize the data properly. When you delete, it will create a lot of gaps. For example, I create something here, I'll delete something here. Now I cannot accommodate anything because data is organized properly. You're deleting a lot of things here. Okay. When you delete a lot of data, it can delete and it leaves what is called as the data gaps. These are called fragments. Okay. So normally, whenever you're deleting something from the data pages, it will delete the row. It is not going to organize any data, reorganize the data, simply deletes the data. Okay. So it will create a lot of gaps in between. So you're going to be, getting a lot of space, but in between you have a lot of gaps. For example, bulk insert, bulk delete operations when you're doing. So whenever you delete the data, SQL Server is going to be deleting from the physical position of the hard disk, but it will have a lot of gaps in between. This empty space is called as a fragment. Okay, so normally we'll say defragmentation. When you say defragmentation, it is going to be taking and pushing the data, neatly without having any gaps in between. So that is what is called defragmentation. Okay, fragment means whenever you delete the data physically, the deletion is not going to be taking place. Okay, try to understand. Even though you delete a lot of data, now the table size is till it is going to be showing 10 KB, 20 KB only. Because even though you deleted half of the million of the data, still the table size is a 10 MB, 20 MB, or 1 GB of data. But if you wanted to see the real size after deleting the data, what we need to do, we have to give a command called rebuild index or reorganize index. When you say rebuild and reorganize index, the empty gaps will be there in between. Those will be deleted and the complete data again reorganized, and a lot of page numbers also will change, because initially you may have 1,000 pages and 1,000 numbers. Lot of deletions have been happened. Again, all the data will get reorganized when the deletion is happening, and it will create again a special index pages for this. For example, tomorrow you don't have rice in the second room. So what you do? You will not be able to keep forever the second room is keep pending, right? So because the rice is over, you have deleted no rice in this room. So what you do? Or no, stationery is available in this room. So will you keep rice in this, and 2 and 3 is completely empty, and in the fourth room you have a fruits. And tomorrow what you do? Since these are empty, you're not going to get anything here. So you will be reorganizing. So the fruits will be occupying a room number 2, and the next item is available in room number 3. So when you're reorganizing the data, that is what is called rebuilding, reorganizing. Clear? So what happens is that, so the all the fruits will come to the here, and according to that, the index pages also will get rebuilt. Okay. Now fruits are not available in the page number 4. The fruits are available in the room number 2. Clear? So when you insert the data, the indexes are created. When you're deleting the data, when the data is gone from that room, gone from this page, you will have a lot of gaps. Okay, to remove the gaps, so what normally we do? Defragmentation. So how can we do the defragmentation inside SQL Server? You have to use a process called rebuilding index. Okay, or reorganizing the data pages. When you reorganize the data pages, what happens is that all the empty pages will be deleted, and these pages are properly ordered. And again, the index is also neatly built, and the page numbers and everything, room numbers and everything will be rearranged and rewritten over there. So this is what is called indexing mechanism. Internally it's going to be doing it. Clear? So whenever you insert the data, update the data, so when you have index, so definitely it will take a lot of time, and lot of things are very very slow when we are talking about indexing mechanism. What is very very faster? Only the reading is very very faster. So try to understand. Okay, now heap is good when you have OLTP kind of a architectures, but we'll have OLAP or data warehousing environment where you have to create more and more indexes, because there we never insert the data on daily basis. Okay, we insert the data once in a moon, once in a quarter we insert the data with the help of a SSIS package. But later you're not going to be inserting the data. Maximum time you will be able to read the data. Okay, when the reading is needed, so then what we need to do, we have to create much more indexes. If the writing is available in OLTP applications, we should be able to go what is called without indexes, that is what is called heap structure. But in the OLTP also, people are not going to, not going to, keep any heap structure. They will be keeping everything, at least, few indexes they will create. But by the, this one. So whenever you create a primary key, I would like to tell you something. Whenever you create a primary key, automatically SQL Server is going to be creating a clustered index. Okay, even though we say indexes are not recommended, but at least a few indexes are there already in your OLTP tables. Okay, so in a maximum you can have one clustered index we can have. So we are talking about types of indexes, right? We can have one clustered index per table, and we can have remaining triple nine non-clustered indexes per table. Okay, so why we need to create more than one index, and all of them we'll discuss in the tomorrow's class. But today let us talk about, think about it. Okay, whenever you create a primary key, what happens is that automatically clustered index will be created. So clustered index only we can create. Okay, so that is with the primary key only. We are not creating any index. We are creating only the primary key, but the primary key is internally creating a clustered index. That you need to understand. Only one primary key and one clustered index we can have. Okay, so clustered index is going to be sorting the data, because I told you, right? The data has to be organized. And after that, what is going to be happening? The index pages are created. So all of them, when you create a primary key, internally all things are happening that we do not know it. That's it. We are not aware that it is not happened. We did not do it, but there is a clustered index. You can see any table with that, ordered man. For example, let me show you this table. Okay, I did not sort the data. So when I created a clustered index on this column, now see you have 101, 102, 103. The data is organized already. So I put 101 here. Tomorrow I may insert any row also here. For example, let me insert one row. Copy. I am inserting into account master values. I would like to insert, let us say, I would like to insert after 162, I'll say 163. Okay, 163. I'll say Vinay. Okay, I'll keep the address as US, and the branch I'm talking about BR6, and say his opening savings bank account. Let me say date of opening is get date, that is today's date, comma, clear balance is zero, and clear balance is also zero, and the status is operational. Okay, like that I'm creating. Let us understand where the data goes in and sits. Now 162, I think it is available already. Do we have 160? Let me give 165 then. Do we have 165 or something? 162 is there. 165 I'm inserting. Let me see this. I have got inserted. When you see the row will not be at the end. So the 162 is 165 got inserted in between. Clear? So it is completely organizing the data. I did not sort the data. Did I sort the data? No, I did not sort the data. But if you see, all the data is physically sorted. Okay. So on the primary key column, you never mention, I would like to again sort the data, because the data will be in the sorting manner. Even though you're inserting the data, it is going to be occupying in the appropriate manner. Okay. So tomorrow we'll talk about why the primary key, why, primary key is creating a clustered index, why only one clustered index, per table, why we have to create much more, non-clustered indexes. All of them we're going to be discussing tomorrow. And today I spoken about what are the advantages of indexes, what are the disadvantages of indexes. Disadvantages means the indexes, when you create, what is going to be happening, the insertions, deletions, updations, data writing will be very very slow, but data reading is faster. But when you don't have an index, what is the advantage? Advantage is the writing is faster, reading is slow. So it is not that I need only the index or I need only the without index. You need to use when is that I have to go in for index, when is that I should not go in for index. That is the important thing that we'll see tomorrow. Thank you, guys.